Hello everyone, my name is Pawan Arora and I'm here in front of you with a new video, and this time I'm covering one sample and two sample T-test. Okay, if you are from Lean Six Sigma background, I hope you heard about hypothesis testing. Okay, and this is also one of the hypothesis testing which called one sample T-test and two sample T-test. So I'll show you first how to do it in Excel, and then we will use Minitab to do the same analysis. Okay, so without wasting any time, let me directly go to the topic. You can see there is a meditation time, medication time A. This is the data which I collected and I'm using for some of my videos as well. So this is a medicine A, and we have a data of medication time for all these medicine. Okay, and we are checking for this particular medicine the average is 95 minutes or not, and the target which we are taking is it should not be more than 95 minutes. So please understand when to use one sample T-test. If you have this kind of data, maybe the medication time, maybe the vendor delivery time, maybe you have data of anything, any particular, let's say if you are from manufacturing, maybe you will have the data of lead time, and you want to check whether the lead time is more than 95 minutes or 90 minutes or some other number. So you can use one sample T-test. In other way, we are checking the average of our data with some of a target value. So if we have this kind of data, then we have to use one sample T-test. Okay, if you know the standard deviation or the population standard deviation as well, then you can use one sample Z-test. Okay, so let me just copy this and paste it in the Minitab directly. Okay, now so what we are doing is we are checking the medication time. The average medication time is more than is greater than 95 or not, but our target is it should not be more than 95. So I'm checking whether this average of medication time is greater than 95 or not. If it is greater than 95, it means this medicine is not so good or not relevant. Okay, so how to check that? You have to go to stat, basic statistics, and one sample T-test. As I mentioned, you can also use one sample Z-test, but in this one sample Z-test you should know the population standard deviation. If you don't know, so you can use one sample T-test. Just click on this one sample T-test, and there are two options. So I'm using the one because I'm using the first one because all my data in one column, right? Just click this, performed hypothesized test. What is hypothesized mean? This is 95. This is my target value which I am looking for. Then go to option. So I want to check whether the mean of this data is greater than 95 or not. Okay, so if it is greater than 95 means it is not a good medicine. So that's why I'm selecting mean greater than 95. Click OK. In the graph I can use box plot if required, and then OK. So firstly I will show you the data in the session window, and then we will review our box plot. So in the one sample T-test, you can see on the top there are two hypotheses called null hypothesis and alternate hypothesis. So our alternate hypothesis is our test mean, or the value of all these, or the average of all these data points is greater than 95. This is our hypothesized or alternate hypothesis, and this is a null hypothesis. This is equal to 95, right? So by looking at the entire data, you can directly check your p-values. If it is greater than 0.05, actually it is much higher than 0.05, so you will say yes, I will I cannot reject the null hypothesis, so I will say its mean is equals to 95, or in another way I will say mean is not greater than 95 because our alternate hypothesis is greater than 95. So by looking at this entire information or entire statistics, I would say the average of my data is not greater than 95. It means this medicine is relevant to us. Okay, same information you can get from box plot. So if you open the box plot, let me increase the size a little bit. So in the box plot, you can see this is your hypothesized value, which is 95, which we are taking about 95. And you can see this blue line is your confidence interval. So here, if you see your session window, this is your confidence interval, because we are checking only one tail or the one side, not two-sided, right? If it is one side, so it will show me only the lower bound value, which is 93.879, and above is till 100, right? So if my data means 95 is higher than this 93.879, yes, it is higher than this, so that's why it is under this confidence interval or under this 95% lower bound. So if it is under this 95% lower bound, definitely my p-value will always be higher than 0.05. If this h0 is in this side, okay, assume it is in this side, then definitely you will be having your p-value less than 0.05. Let me show you that as well. So just press Ctrl E, you will be on the last window, and instead of comparing with 95, let's say I am checking whether my test mean is greater than assume 92, okay, and I click OK. Now in this case, you can clearly see this is your value of 92. It is not in your confidence interval or not in your 95% lower bound value. So definitely your p-value, you can see here in the session window, is less than 0.05. So in this case, we have to reject the null hypothesis. So I will say my hypothesized mean or my average of medication time is greater than 92. Okay, so I will go with the alternate hypothesis. So that's how you can use one sample t-test. Okay, now let's go to the another test, which is called two sample t-test. Let me delete the session data first. Let's go back. Suppose you have two medicines or a same medicine but from different companies. Okay, let's say company A medicine and company B medicine, and I have collected the information about the medicine from company A and then medicine from company B, same the medication time, and I want to compare which is good or whether they are equal or not. Okay, so firstly I want to check whether they are equal or not. I have to use two sample t-test because there are two samples, and I am checking the average of these two is equal or not. So what I will do, using Minitab, I will just copy this and let me just paste this data somewhere here, and let me delete all these rows or columns. Okay, now you have two data points, as you can see here, right? Just go to stat, basic statistics. Here you have two sample t-test. So when you click on two sample t-test, now there are two options. First, both samples are in one column. No, in our case, each sample is in its own column, right? So we have to select the second option, then the sample 1, sample 2. In the option part, definitely you are selecting this part. Difference is not equals to hypothesized difference, and what is the hypothesized difference is 0. Why? I am checking whether these two are equal or not. So these two are equal means the difference of this C1 column and the C2 column will equals to 0, right? So I'm checking that part and click OK. In the graph also, if you want, we can have the box plot and click OK. So box plot I will compare in later on, but let's talk about the session window, which is very interesting now. So if you see here, you have two data, one from the medication time from company A, and this is medication time from company B, and these are their standard error of mean, and this is the standard error of mean of other company. I already have a video of standard error. You can go there and check what exactly is standard error. Okay, so how this test or how this hypothesis testing is done in Minitab, it will take a difference. So difference is nothing but the average of company A minus the average of company B, and if you see the difference is coming minus 0.233, I will show you in the Excel as well, and then it will use a 95% confidence interval formula is this, And according to this value, so this is your confidence interval of 95% because our significance level is 95% and alpha risk is 5%. Now what we are checking is, we are checking the difference of these two is equals to 0, which is our null hypothesis, and alternative hypothesis, it is not equals to 0, right? So it can be checked in two ways. Firstly, I can go directly to the p-value and I see, okay, the p-value is 0.698. Now if the p-value is 0.698, it means I cannot reject the null hypothesis. I fail to reject the null hypothesis, then I will say, yeah, difference is equals to 0, right? But in reality the difference is 0.22233. But according to the statistical part, if your difference is falling under the confidence interval, in the sense 0.233 is falling under these two values, yes, obviously. So that's why your p-value is greater than 0.05. So if it is greater than 0.05, it means you have to reject, you cannot reject the null hypothesis. It means the difference is equals to 0. And if the difference is equals to 0, then I will say the medication time of company A and company B are equal. Similarly, if you want to check, let's say, lead time by machine A and machine B, or by company A or company B, or you want to check whether the vendor delivery time of company A or company B. So same thing you can use, and you can use the two sample t-test and check your hypothesis according to the p-value or according to the confidence interval. So if your value, this value is falling under this, definitely you will be having, you cannot reject the null hypothesis, right? So this is two sample t-test. Now I want to show you in Excel how you get this difference and how you get this confidence interval. Okay, let's go back to the Excel file. So if you see, it's very simple. I have taken the average of A and average of B. Average of A is nothing but the average of all these data points. Average of B is nothing but, if I just press F2, this is the average of company B, right? And I have also taken a difference. So difference is nothing but the difference of these two, this minus this, this minus this, this minus this, or you can take vice versa, means company B minus company A, nothing will change. Okay, and if you see the total difference, this is the difference if you add all together, so not addition, the average of entire difference is here. So this is called difference average, right? So 0.232, 0.233. So you can get this number from two ways. One, you take the average and take the difference of these two. So indirect way, you can do this minus this, or the other way is equals to average, right, of this entire data. And close. So this is same 0.233, right? So this is how you can check the difference, and you can get the average of difference. Same way I've calculated the standard deviation of this difference, correct? So this difference is what actually? This is nothing but A minus B. So I'm checking the average of this entire difference, standard deviation of this difference, and then standard error. So standard error is nothing but your standard deviation of the difference. Let me do for you, equals to this divided by square root, okay, of number of data points. You can see my other video which will show you, or which will tell you how exactly you can calculate the standard error. So this is your standard error, right, of the difference, and the same standard error is already given in the Minitab as well, if you want to check the standard error of that. And then you will have the degrees of freedom. So degrees of freedom, the total degrees of freedom for one part, you have 33 plus 33. So total, how many data points you have? If you check, you have 68 data points, right? So 68 data points, and you have 34 data points for this, and 34 data points for the other one. So total 68. So 60. So for first one, the first company, you have 34 data points, so degrees of freedom is 33, which is n minus 1, and for the second one also you have 34 data points. So for this also you have 34 minus 1, so 33. So total degrees of freedom you can consider is 33 plus 33, 66. Now when you go to the T table and you check for 95% value, the value is 2.97. Okay, with 66 degrees of freedom, because your T table will tell you according to the degrees of freedom. I am also making another video how to check the values in the T table. You can go through that video, and then you will have a confidence interval. So confidence interval, the formula for confidence interval is also given in my another video. You can go through, but I want to show you again. So the formula you can see here, this is nothing but the average plus your 95% value of T table, or T value I would say, multiplied by the standard errors. Okay, this is in the plus part, and same way there is a formula for minus, which is nothing but your average minus the 95% value from the T table multiplied by the standard error. So this is your plus and minus value. Both the values you can see in the Minitab as well. You can see this is the value of confidence interval. So it is coming from the difference column. It is not coming from here, because difference you have to take, and then you are checking whether this difference a minus b is equals to 0 or not. Okay, so null hypothesis means they are 0, and alternative hypothesis means they are not equals to 0. And in our case, when I checked through the p-value or through this confidence interval about this difference, it shows that they are equals to 0. It means they are not equals to they are equals to 0, means the company A and company B medication time is equal, right? Now let's move on to the last part of this video, which is called paired t-test. So we also have two sample t-tests, and the same way we have the paired t-test. Now what is the difference of these two? As I said, if you want to compare company A, company B, or the delivery time of vendor A, vendor B, lead time of, let's say, particular company A and company B, something like this, or machine A, machine B, equipment A, equipment B. But in these cases you will use two sample t-tests. But in case, suppose you have before and after situation. Assume you have done a project, okay, and you have improved the medication time of a particular medicine. So you have this medicine, right? And you have improved the time of this medicine, that you have done some improvement, and you have the after data of medication time. And then you want to check whether there is any difference between the medication of A and medication of B. So in these cases, you are having the same medicine, right? And you are doing some formulation change or some addition of something, and then you find there is a difference, and you want to check that difference, whether there is a significant difference or not. Okay, in these cases, you have to use paired t-test. Paired t-test means it's connected with the same thing. So in this case also, you will use the same fundas like difference, confidence interval, the same way which we have calculated here. But the only difference is here you have to use the paired t-test. Let me just go back. Okay, and let me minimize this window. Okay, and let me delete this session window. Let me delete this old data as well. Okay, and let me paste these cells. So now I have the medication time of A before and A after. So this is the same medicine. We have done some adjustment in the formulations or in the process, and we want to check whether these process is improved or not. Okay, or indirectly I want to check the medication time of A is better than the medication time of A after is better than the medication time of A before. Now how to do it? Medication time means lesser time is better than lesser time is better. So I want to check the medication A after is lesser than the medication A before. Okay, so how can I check is, just go to stat, go to basic statistics, and select the paired test. Okay, click OK. Now again you will have two options. One is each sample is in a column, yes. Then the medication time of A, medication time of A after. Again, let me repeat, what I want to check is the medication time of A after is less than the medication time of A before, right? So that is why I have to select this kind of option. So now if I am taking a difference by default you can see the difference is sample 1 minus sample 2. So you have to be little bit careful here. Now here you have sample 1. If you are putting A before as a sample 1, then sometimes you will be confused. Okay, so better you just delete this and select sample after in your first column and sample before in your second column, and then go to option. Now you see, so sample 1 is nothing but your medication time of after, and this is medication time of before. So after minus before, what I want to see is it should be less than the hypothesized difference. And what is the hypothesized difference? Is 0. Please understand this. So if you have after minus before is less than 0, it means after is less than before, right? After is less than before. So I am checking whether after is less than before or not. Okay, click OK and then OK. So when you click OK, what it will give you, try to understand this now. So my mean or difference is equals to 0, and I am checking this alternative hypothesis is less than. So according to the p-value, I have to reject the null hypothesis, right? Because the p-value is 0.005, which is less than 0.05, right? So it means I have to go with the alternative hypothesis. And alternative hypothesis is what? My A after medication time is less than my before medication time. It means whatever the improvement I have done in this process is good. It is reducing my medication time. Okay, so this is how you can check the difference of these values and see. And even on the top you can also see your medication time after the average is 95 and medication time before the average is 96. So from here also you can get some kind of feeling. The other thing is, if you just press Control E, go to the graph and select the box plot, click OK and OK. So even in the box plot also, the box plot is not coming for 2 like for A or before, but it is coming from your difference. You can see the box plot of differences, right? So in the difference part also you can see this is your hypothesized value, which is 0, and you are checking from this entire data, and this is your 95% upper bound value. You can see in the session window is minus 0.569. So it started with minus 0.569. You can see here. So that's why 0 is not in this interval or in this area. Okay, so if not in this area means you are having p-value less than 0.05, which is showing here, and finally you will reject the null hypothesis. If you are rejecting the null hypothesis, you will go with the alternative hypothesis and you will say yes, the medication time of A minus medication time of A means after minus before is less than 0, which means after medication time is less than the medication time before, and yes, my medicine is working good. It has improved the medication time, right? So this is how you can use one sample t-test, two sample t-test, and paired t-test in different kind of data. But please note, you should have, for one sample t-test, you should have one set of data. For two sample t-test, you are checking data A with data B or data 1 with data 2. But if you have more than this, maybe 3 or 4 data point, in these cases, you have to use ANOVA